Hey guys, welcome back to the channel. In this one, we're going to be looking at vectors. First, we're going to discuss vectors and scalars. You might have learned this in either physics or math, and let's get into it. Quantities which have only magnitude are called scalars. They only have a number associated with it, and it does not matter whether it's positive or negative. And examples of these would be speed, energy, distance, and power. You know that if I walk at 2 meters per second in the right direction, would also be the same as walking to the left with the same speed. Here, the speed is the same, but the velocity is not the same. In the first example, it's going to be plus 2 meter per second, and in the second one, it's going to be negative. This is because vectors they have direction. So quantities which have both magnitude and direction are called vectors. The examples are velocity, force, displacement, and momentum. To represent vectors, we use a head-to-tail representation. Let me show you what I mean by that. We draw a line segment and we're going to draw an arrow. This would represent the head and this is the tail. We go from the tail to the head, and that's how you represent a vector. But what is a vector? It is a scaled directed segment. It has both magnitude and it has a direction. A vector can also be this, 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 and so on. We can add vectors, we can add these two, we can subtract them, and then we can multiply them too. And now we're going to look at position vectors. A position vector essentially tells you the position of the vector with respect to the origin. The origin would be 0, 0, right? And this position vector will tell you how far it is from this point. So that's what is a position vector. And it can be represented as OA, where O is this point and A is somewhere on the plane. So it goes from O to A. We have to use this arrow on top um, to tell them that it's a vector. Or we could use a capital A, no capital, sorry, bolded A to represent a vector. But while you write on the paper, it would be more convenient to write A dash or A thing. This is often used in textbooks while printing, but it's going to be hard for you to draw a bolded letter. And so we use this. This would be OA and this is A. The magnitude or length can be represented by the magnitude of this or just OA. OA would be the length and either this, or this. We're going to learn about magnitude soon, but it's like you can think of it as the distance, like how long it is. And that's what a magnitude is. And now we're going to look at AB, which is the vector AB. It's the vector which originates at A and terminates at B. Like I said, this would be the tail and this would be the head. And therefore it starts at T and ends at H. Or I mean starts at A and ends at B. And the AB is the position vector of B relative to A. Relative to A, B is the position vector. No, AB is the position vector. Usually when we say position vectors, we mean with respect to the origin. But we can also write this statement, which would also be valid. And now we're going to look at how to represent a position vector. Just imagine the point P with coordinates x and y. It has a position vector of OP. So we can represent it in two ways. The first one is called as the component form, and the next one is the unit vector form. In the component form, we represent it in a column form. The top is going to have the x component, and the bottom is going to have the y component. And we can just write this as this, which is also the same. This we represent it as the unit vector form. A unit vector is just, it has a length of 1 and is often used to tell you the direction. It's mostly to use to let people know about its direction, and it has like a magnitude of 1. Let's talk about what I and j are. Like I said, it's going to have magnitude 1. So I is 1, 0, and it is a base vector in the x direction. This is how it would look like. If this is a magnitude of 1, then this would be I, and j would be this. And that's how you plot them. I in the x direction and y in the the I in the x direction and j in the y direction. And the set of vectors I comma j is the standard basis for two-dimensional x comma y coordinate system. You can just plot it like how you would normally do. Let me give you a few examples. So we have to first represent the following vectors. Let's do that. Let's use a different color. For A, we have 2i minus 4j. You know that I moves in the x direction and j moves in the y direction. So we just have to plot 2 comma minus 4. This is 2 comma minus 4. 2 minus 4. This would be A. Let's plot B. This is 5 comma 6 because both of them are positive, so it's going to be 5, 6. This is B. I'm writing capital, but you're supposed to write lowercase. And then we have this. It's going to be negative 4 comma 3. Negative 4 comma 3 would be 3 up. This is C. Now let's do the last one. Minus, okay, look at this. This is J, right? So it's going to be, wait, let me use a different color. Purple. Okay. This is going to be minus 8 comma minus 9. This is because this is I and it's going to have the x coordinate, and this is y, so it's minus 9. It's minus 8 minus 9. It's going to be somewhere here. This is D. So this is how you represent vectors. I hope it was simple. It's just like plotting the x and y coordinates. Now we're going to look at vector equality. Two vectors are equal if they have the same magnitude and same direction. Essentially, their x components must be equal and their y components must be equal too. And equal vectors are parallel in the same direction and are equal in length. The arrows that represent them are translations of each other. Alright, so this has the same magnitude as this and this, and they have the same direction if you look at it. And therefore, these three vectors are equal. If you have this one, let's say this is B, this is not, these two vectors are not equal, but this would be, because they have the same magnitude and they have the same direction. And if they were like in opposite directions, this would be minus A because they're negative vectors. We're going to talk about that soon, but just remember that if it has the same magnitude but opposite direction, it's called as the negative vector. And this would be negative B. It just means that it goes in the opposite direction. Okay, yeah, it's right here. It's negative vectors, right? So AB vector and BA vector have the same length, but they have opposite directions. We say that BA is the negative of AB. So therefore, we write this. When we break this down, you'll understand why this is that way. You may not understand this right now, but you'll understand why this is when we do, I think, the subtraction and addition of vectors. But I'll just tell you how this works. So this is OA minus OB. This would be minus of, this would be OB minus OA. This would be OA minus OB. These two are the same, right? And hence, this is in fact true. And A and minus A are parallel and equal in length, but opposite in direction. That's what a negative vector is. They're same magnitude, same length, but opposite direction. I'm hoping that these concepts are clear. And now it's time to move on to the questions. Let's read the first one. We have to write the illustrated vectors in component form and in unit vector form. All right. So we have this. So first, let's say this is 0, 0. It's not going to be, but let's just consider that. And now we have to find the length in the x direction and the length in the y direction. So this is going to be 1, 2, 3, 4, 5, 6, 7. So therefore, it's 7i because this is I, and so on. And now let's look at the y direction. It's going to be j, j, and j. And therefore, it's 3j. In component form, it would be 7, 3. 7, 3. And in unit vector form, it would be 7i plus 3j. Let's look at this one. This will be minus I because it's in this direction, in the left direction. This is minus I, minus I, minus I, minus I, and minus I. We have 1, 2, 3, 4, 5, 6. So it's negative 6i. And there's no y component. So it's going to be 0j. In component form, it would be minus 6, 0. And in unit vector form, it would be minus 6i plus 0j. We have to write in component form and illustrate using a directed segment. So the first one, let's use purple. We have to write in the component form. So it's going to be 1, 2. And this is going to be simple. This is I, J, and J. So therefore, this is going to be this is vector A. And now let's look at this. This is minus 1, 3. Minus 1, 3. You just think that's a straight line. Yeah. Okay, that's B. Now let's do C. Minus 5. This is easy. Just a straight line. This is C. This is going to be 0, minus 5. and we have to write down the negative of this. It's just going to be -1. We just have to put negative, 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 plus, negative, negative, plus. You just have to negate it, and that's all.